Alrighty, I think we've plateaued with some attendees, so we'll get things started. Welcome to today's session on valuing Canada's water resources and aquatic ecosystem services. This session is being convened by Roy Brower and Patrick Lloyd-Smith. And I'm just going to get it kicked off here to get us started as welcoming remarks to the session. So first off, I'd like to start today's session by acknowledging that I'm welcoming you from Saskatoon in Treaty 6 traditional territory of the Cree and homeland of the Métis. Because we are participating virtually from across the country, I invite you to take a minute with yourself to acknowledge land from where you live and work. In doing so, we're asking the lands to provide us with a positive environment for today's sharing and discussions. So just a bit of housekeeping. There will be a question and answer period at the end of today's session. So if you have any questions for any of the speakers today, please use the Q&A function that you find at the bottom of the screen. The session is being recorded and will be shared on the Global Water Futures 2021 website. The slides will not be shared, but please feel free to reference back to this recording if you need to. If you are wanting to use closed captioning, that has been enabled. So please click on the CC button at the bottom of your screen. And then lastly, if you'd like to join this conversation on social media, please use the hashtag GWF2021 and we'll try to keep track of it. And then as you guys are all aware, as you sign into the Global Water Futures 2021 platform each day, there is a code of conduct that we ask you to follow. Although we are encouraging rigorous scientific debate here, we do ask that you do so in a respectful manner. So the code of conduct is listed here and we'll also link to it in the chat if you want to read it any further. So without further ado, I'm going to pass it on to Roy and he's going to get this session started for you. Thanks, Roy.
Thank you, Tracy. Can you see my slides?
Yes, we're good.
So before I start and introduce everyone, I also want to acknowledge that I'm on the Haldimand Tract, land that was promised to the Haudenosaunee of the Six Nations of the Grand River, where I live. The Haldimand Tract is within the traditional territories of the neutral Anishinaabeg and Haudenosaunee peoples, and I would like to acknowledge that I am on that piece of land. So thanks, Tracy, for the housekeeping announcement. I'm now trying to go back to my slides, which I struggle to find. So you can still see my slides, is that correct?
Yes, we're seeing valuing Canada's water resources.
And it's in the presentation mode.
It's not yet. There it is. Now it's in presentation mode.
Okay, perfect. So welcome everyone to this session. It's a session based on a new Global Water Futures project. We're very grateful to the Global Water Futures leadership for approving this new research project. We started in September last year, and we is myself, Roy Brower, here at the University of Waterloo, and co-PI Patrick Lloyd-Smith at the University of Saskatchewan. I'm here with a number of other people from the University of Waterloo, Helen Jarvie and Ruth Pinto. And from Brock University, we have participating Diane Dupont, and from the University of Alberta, Vic Adamowicz. And the names that you see here highlighted in yellows are the people that are also going to give a short presentation in this session. So before we start with the presentation, I just thought of introducing the new project to you. This is our main objective. We hope to be able to advance our understanding of the socioeconomic values of water. And we hope to be able to do so by developing best practice guidelines that we then would like to test in practice and then use the results from these tests and these guidelines to develop new policy relevant decision support tools. The project is organized according to themes, and here you see the three themes that we identify. The first theme is to better understand and guide Canadian water valuation, research and And we are aiming under theme B to expand the water valuation information base by testing the guidelines that we're aiming to develop and then use the results in decision support tools. This is our timeline. As I mentioned, we started on the 1st of September last year, so we're a good 6 months or so into the project. And we've started off by identifying what do we currently know about the Canadian water values. And then I'll present after this a little bit more about that. And we've started thinking about drafting valuation guidelines. And then in year 2, which will start on the 1st of September this year, we aim to apply and test these guidelines in specific case studies across the country. And then in year 3, we hope to be able to use the results from the case studies to validate the guidelines and to use these results in the development of an online decision support tool that will help policymakers, practitioners to better identify the so-called non-market values associated with water use. And what non-market values are is something that we will refer to in this particular session. So just some progress that we've been making so far. So we've been actually able to finish a review of the Canadian valuation literature. I'll talk a little bit more about that. And we have people on board who were part of an extensive multi-year project drafting guidelines for so-called state of preference studies aimed at eliciting public willingness to pay for environmental changes. And a lot of that knowledge will go into the development of the guidelines in this project. This is the overview of the session program. So I'm in the opening at the moment, and then I'll continue talking a little bit more about what water is worth in Canada, looking at what data and information is available. Then we'll have Diane give a presentation about water valuation in Canada, past, present, and future. And this will then be followed by a presentation by Patrick, who looks at the quantification of economic value of water quality through behavior. And then at the end, we'll have Ruth Pinto from the University of Waterloo, who will focus on methodological challenges linking water quality changes to recreational demand. We'll have presentations of around 15 minutes that will give us then 5 minutes after every presentation to ask some questions. And then at the end, we hope to be able to have a discussion about how we can move the water valuation agenda in Canada forwards. And we hope to finish and end at around 2:53 o'clock. So one of the other things we've done so far in the project is to create a project website. You see the address here at the top. And so if you are interested in following the progress that we're making in this project, please go to this link. So that is the very short introduction of the project. And unless there are any questions so far, I don't see any in the Q&A box. I propose I continue talking and present some of the preliminary work that we've been working on in the project by doing a review of the Canadian literature. So this is joint work with Ruth Pinto from the University of Waterloo. What we did was a so-called meta-analysis of the Canadian non-market valuation literature. And non-market valuation is related to the fact that a lot of the goods and services provided by water are public in nature, meaning that they don't have a market price. They're not traded like a lot of other goods and services through economic markets. So their market value, their market prices are unknown, and economists have developed all kinds of ways to elicit these values by alternative ways and methods. So that is what these non-market valuation studies focus on. They're trying to elicit in many, if not most of the cases, what public willingness to pay is for the goods and services provided by water resources. And willingness to pay is an important concept in economics to estimate value. Ideally, we do it through observing actual behavior of people. That is the most reliable indicator of value, but in cases where these markets are not existent, which is often the case for a lot of goods and services provided by water, we simulate markets and we ask people more hypothetically what their willingness to pay would be if a hypothetical market would be put in place. And that's the kind of literature that we reviewed in this study, where the main question answered was how much are Canadians willing to pay for water quality improvement. So we focused very specifically on water quality in this study. And the reason we're doing so is that there is this idea that there is a lot of water in Canada. There is water abundance. And so water security is not really an issue. And our belief is that that is based on a misperception. There is a lot of things going on in the country: urbanization, agricultural intensification, industrialization. Our watersheds become more and more populated. There's a lot of land use change going on that affects directly or indirectly the quality of our water resources. So even though we have a lot of water resources, those water resources may not be directly usable for all kinds of purposes. And hence the goods and services provided by these water resources are under increasing pressure. And the moment these goods and services are less and less available, this becomes an increasingly important issue in economics. So economics is all about analyzing scarcity. The moment something becomes scarce, it has the interest of economists, and it has value. Even though there are no prices available, water becomes valuable the moment the water availability and the quality of the water becomes scarce. And so we have these different types of approaches to then try to estimate these so-called non-market values of water. And such a systematic review of what these non-market values of water might look like is absent in Canada. And here you see some references to people who have addressed this issue. And so based on that lack of information, that knowledge gap, we started this study. As mentioned, we did a meta-analysis. Meta-analysis is a very structured review of existing empirical evidence, where we're interested in that willingness to pay indicator, and that willingness to pay indicator is expected to vary depending on the good and service that is provided by different types of water resources. We are interested in the influence of different water quality levels on the provision of these goods and services. And then there are populations of beneficiaries that might have different ideas about how valuable these goods and services are. And then there are all kinds of methodological differences between the methods that these economists use to estimate willingness to pay. So this Y here in this model is public willingness to pay for the goods and services provided by water resources. There are different types of water resources, different water quality levels impact the provision level of these goods and services. There are differences across populations across the country in Canada, and there are differences in methodological characteristics of how we elicit these values. And so what our main objective was of this study was to measure willingness to pay across the country and to be able to explain which factors drive the variation observed in these willingness to pay factors, willingness to pay values. Our data search was very comprehensive. Here you see an overview of where we looked for all kinds of studies, Canadian studies, including libraries of Canadian universities, the Environmental Valuation Reference Inventory, which is a big library of environmental valuation studies originally developed by Canada and used worldwide still. It originated in the 1990s, I believe. And we systematically then went through the identification of different studies. This is a so-called Prisma diagram where we list and explain how we went from a large number of studies. 103 studies were identified initially, and then after screening these studies and checking whether they're eligible to be included in our database, where we then end up in the end with a total of 22 studies that meet our criteria. And a very important criterion in this study was that we were interested in identifying how changes in water quality affected different goods and services provided by these different water resources. And for this, we used the so-called water quality ladder that you see here on the right-hand side. And you probably all have heard about fishable, swimmable, drinkable, boatable water quality. It's a water quality ladder that was developed in the 1980s in the US, and it's still in use by the US EPA, Environmental Protection Agency, to make the translation between different water quality levels and the usefulness of that water for different human activities. So that is what we tried to do when we identified these different Canadian studies, link it to this water quality ladder, which would then allow us to make the different studies that were carried out in Canada comparable. This is an overview of the 22 studies that we ultimately worked with, studies that met our condition that they had to say something about changes in water quality. Out of the 103, a lot of studies focus on water resources, wilderness activities, recreational activities in wilderness areas, but not necessarily related to water quality. So only 22 studies meet that objective, and they're plotted here on the map of Canada. Most of them are found in the southern part of the country, where most of the people live in Canada. Around 50% of the studies were carried out in the 1990s, and then about a third after 2010. And you see some concentrations of these studies in the eastern part of the country here, and then here on the southwestern border in British Columbia and Alberta. And only a few of these studies actually make the link with the water quality ladder. Less than a quarter of these studies made use of that water quality ladder, and hence it became quite a challenge for us to make these studies comparable, because different indicators were used to measure changes in water quality, using categories like poor, moderate, good, or excellent, to indicators that were measuring turbidity, for example, of the waters. In other studies, there was they used information about the amount of phosphorus or nitrogen in the water, phosphorus running off into the into surface water, and we also included groundwater studies here, and nitrate was the dominant pollutant in these studies. So these different studies use different ways of representing the pressures exerted on the water bodies, using different water quality metrics, and our biggest challenge was to make these changes in water quality that were driving then public willingness to pay, to make these changes in water quality levels comparable, using the water quality ladder and the water quality index that is underlying this ladder. Let me just go back here. So this is the water quality index here, varying between 0 and 10. And these are some of the results that I can present. So we broke down the willingness to pay values that you see here in 2019 Canadian dollars per household per year. across different categories, whether the values came from studies that were published in peer-reviewed journals, or whether they were non-peer-reviewed, whether the willingness to pay value was on an individual level or per household, whether it was annual or less than annual. This should be compensating surplus and equivalent surplus. These are two different welfare measures in economics. The consumer surplus or compensating surplus measures willingness to pay for an improvement in water quality. We also had some studies where respondents were asked for their willingness to pay to prevent a deterioration of water quality. Different payment vehicles were used. When you ask this willingness to pay question, you can use the water bill, you can ask them to pay through a general income taxation increase. And these are the three main valuation methods that were used in the studies that we identified: continued valuation, choice experiments, and travel costs. I don't have the time to explain the differences between these different methods, but they generate different values, as you can see here. And this is a little bit more information across categories. So these willingness to pay studies were conducted through in-person interviewing, mail surveys, internet surveys, phone interviews, and again, that also generated different willingness to pay values. The distinction was made between users, non-users, or a combination of users and non-users. Again, that generated different values. And we found different values for different water bodies: rivers, lakes, aquifers, and combined water resources. Combined water resources typically were watersheds where river and groundwater, for example, was combined. We also looked at differences in willingness to pay values based on whether or not specific pollutants were mentioned or not, and whether a reference was made to the water quality letter or not. Yeah, so a lot of differences in these willingness to pay values were found. The data was very heterogeneous, so to say. It was covering a very large area. Canada is a very big country with very different specific contexts, using different methods to elicit these and measure these public willingness to pay values. And what we then tried to do was to identify the main explanatory factors for these willingness to pay values. This is how we managed to plot the mean and median values for willingness to pay using the water quality ladder. So as I mentioned, it starts with boatable, then goes to fishable, swimmable, and drinkable. Here you see the number of observations we managed to find in the different studies, the 22 studies. The differences are statistically significant, and you see, as we expect, that willingness to pay increases as the water quality improves and goes from boatable to swimmable, from swimmable to to fishable, from fishable to swimmable, and from swimmable to drinkable. These are the some of the regression results. We find a negative time trend, which indicates that the values become more conservative as we go through time. So we investigate almost 30 years of valuation research in Canada, and there's obviously also a development of the studies that become better, and there are more best practice guidelines that are being followed, so the values go down in time. We find some differences that we also observed in the univariate analysis that I just showed you. A distinction was made between willingness to accept compensation for environmental damage to water resources and willingness to pay for water quality improvements. If you ask the willingness to accept question, then you get a significantly higher value than the willingness to pay value. We also controlled for so-called external factors, information that we collected outside of the individual studies by looking at population density in the area where the study was carried out, the share of users and non-users of the water services that we were interested in, and household income is another very important explanatory factor of willingness to pay. Basically measures ability to pay, and you expect ability to pay to be of influence for willingness to pay. We also then look at water quality baseline levels and the changes in the water quality. And what we observe here is that the changes in water quality, as you see here, are significant and positive. So the higher the change in water quality, the higher the willingness to pay for all the different water bodies, for the groundwater, for the whole watershed, the river. The only one that doesn't show up statistically significant are the lakes. And another interesting or remarkable finding is that the lower water quality levels don't significantly influence willingness to pay. So the lower water quality baseline levels only start to become significant after they have a score of 5, and then they increase significantly if they become higher than 5. This is a shortcut of the model that I just presented that we're using to predict these non-market values elsewhere. Then that's one of the purposes of doing this exercise, is that we have a value function that allows us then to predict values elsewhere where no such non-market valuation studies are available. And again, you see here that a change in water quality has a significant positive effect. And we include an interaction effect here between the change in water quality and the baseline level, and that has a significant negative effect, as we expected. And so the higher the baseline level, the lower interacting with the change in water quality level, a correction is included for the change in water quality. Yeah, so this negative coefficient is subtracted from this positive coefficient. So people value an increase in water quality, but if baseline water quality levels are higher, then their willingness to pay goes down. That is basically what this negative value is telling us. And this is another important indicator, and that has to do with the reference point from which we are starting. The so-called equivalent surplus welfare measure is significantly higher than the consumer surplus, which means that people value a deterioration of water quality more than an improvement of the water quality. And that's related to what economists refer to as loss aversion. So you value something that you already have, and that you then are at the risk of losing more than something that you don't have, but for which you're being asked to pay to achieve it in the future. And so that is what this dummy tries to represent. What we then are able to do is, based on these functions, is to predict values elsewhere. You can do that by simply doing a transfer of mean values, or you use the simple model that I just showed you, or that bigger full model that I also just showed you. And you see that the mean absolute prediction error then goes down from 95% to around 75%. So if we include control for these explanatory factors, we're able to reduce the prediction error. It's still pretty high. It's still 75%. And the explanatory power of the models that we estimated was around 65%, but it's a significant improvement of some of the valuation functions that have been used from south of the border on the US side, where similar meta regression models were estimated, and where the prediction error was like 1,000% instead of the 95% that we get here if we do the prediction based on Canadian studies only, instead of using American studies. So the number of studies and observations is very limited. That means that we have to interpret the results with the necessary care. We find a high degree of heterogeneity, and a coherent common design is missing. And it's a very nice reason why we started this project, and that is that we are hoping to be able to more harmonize the evaluation efforts in Canada when it comes to changes in the availability and the quality of our national water resources, and doing that in a more harmonized way means that we'll be able to make these values more comparable and also track their development over time, which is currently very difficult to do. And my final conclusion is why we started this project, that there is a need for these non-market valuation guidelines to be improved and to tailor them to the Canadian water landscape. And that was my my presentation. Any questions?
Hi, Roy. There was a quick question about what the units mean for WTP.
What the they're per household per year. Is that what you mean, Diane?
I believe so. I believe it was just a question from our audience here. So, yeah.
Yeah. So these are this is what the general public is willing to pay for the improvement of water quality in different places across the country for different types of water body. And so the literature covers a time period of almost 3 decades, 30 years. And if I remember correctly, the information that I just presented you is based on surveys that included approximately 15,000 Canadians.
Perfect. Would you be able to summarize it as potentially a dollar amount per cubic meter of water?
So that is very difficult. So, and that's where the big difference between the natural sciences and social sciences starts to kick in. So in the social sciences, which includes economics, we focus on people. So it's people valuing these resources, and of course we're paying a cubic meter price for our tap water, but typically the outdoor recreational activities that we're valuing here, for example, are not necessarily measured in cubic meters of water, unless you are interested in how do you call that, wild rafting? Is that the, you go with your boat on these on a water that you see here on this slide, where water flow levels are important, and maybe for some fishing activities.
Fantastic. Thanks so much, Roy.
So if there are no more further questions, I propose I hand over to Diane, who is the second speaker in our session.
Yes, I'm just about to start everything up. So can everybody see that? Stacy?
Yes, we're good, Diane. Thanks.
All right, thanks very much. Good morning, good afternoon, everyone. I'm coming to you from St. Catharines, Ontario. I'm at Brock University, which is on the traditional territory of the Haudenosaunee and Anishinaabe peoples, many of whom continue to live and work here today. And I'm really pleased to have an opportunity to speak to you. So Roy has asked me to speak about water valuation in Canada, past, present, and future. And as you might have gathered from Roy's presentation, there has not been a large amount of work done to value water in Canada in the past, unlike our counterparts to the south in the US, where there are many more valuation studies that have been done, and also our colleagues in the UK, where again, many more valuation studies have been done. So let me start off a little bit about what is water valuation. Essentially, what we're trying to do when we do water valuation is to quantify in dollar terms the benefits of water resources to Canadians. We think about water as an asset, as a very valuable asset to Canadians, and we're trying to figure out what the value in terms of dollars is to Canadians. And as you would have guessed from looking at Roy's presentation, there is no single value. I remember a few years ago being asked by someone, and they said, well, what's the value of water? And I said, well, you want a single number? There isn't a single number. As you saw from Roy's presentation, water provides different types of benefits, and context in terms of water valuation is important. Simple one is quantity versus quality. Roy focused on quality of water, but equally there are issues around quantity, particularly when we're talking about drought situations and insufficient supply. There are also issues around the time period in which the water is being provided and the purpose for which it's being provided. And so all of those different contexts are going to lead to a different set of values for water. And of course, at the end of the day, the other part will be who is actually taking advantage or gaining these benefits from the water. So no single value. And economists and a lot of other people who work in this area like to have a kind of an overarching framework within which to think about how to value water. And so this is called the total economic value framework. It's used for other kinds of natural resources. This one's specific looking at total economic value of water. And I think it's helpful to think about the two broad distinctions that are made when we think about how do we start putting a value on the myriad ways in which water benefits us. And that simplest way to think about things is what we call active use benefits. So if you look on the left-hand side of this chart, you'll see there are three different categories of active use benefits, but then there are equally passive use benefits on the right-hand side. And as we move from the left-hand side, you can see there are, as I said, three categories of active use values. There are so-called direct use values. These would arise from both extractive and non-extractive uses. So for example, fishing, agriculture, municipal water supply, industrial use of water. So those are both hydro. Those are both sometimes extractive. We're using water, we're taking it from the ground, for example, or we're taking it away from the surface, versus non-extractive where we don't remove it from its location. In addition, there are indirect use values, and these provide more functional types of benefits. So for example, Roy talked a lot about water quality in the context of the water quality ladder. A lot of the aspects of that water quality ladder are related to recreational types of benefits that we get from water. So fishing and boating, camping, other types of water-based recreation. In addition, there are health benefits we get from both quantity of water and quality of water. And finally, one of the really important indirect use values is so-called ecosystem services. So water provides water purification, or sorry, wetlands provide water purification, for example. Other types of water, riverbanks and things provide flood control. So there are a lot of benefits that we get that are not as tangible as recreational types of benefits, but still equally important. Option values are essentially future values, both direct and indirect. That's active use, and they tend to be more tangible types of benefits, but equally important are passive use values. And these basically take the form of bequest values. So valuing environmental integrity for future generations, that can be both ecosystem services and other types of values, as well as existence values. And so we can think about cultural values and spiritual values coming from access to water and good quality water and good quantities of water. Now, how do we do water valuation? As Roy mentioned, there are very few actual markets in which there is a so-called market price for water, where you have a buyer and a seller. And so we have to rely on non-market types of valuation. And I believe Patrick is going to be speaking more details about that later. But essentially, there are two ways we go about doing non-market. One is what's called revealed preference. So that's where we look at markets that are related to water. So recreational activities often involve purchases of equipment that would then allow us to infer the value of the water body that's being used with the equipment. That's revealed preference. Then there are stated preference types of non-market valuation. And that involves essentially constructing a market using survey techniques and basically explaining how water quantity or quality could be changed through some form of government policy, and then asking people whether they're willing to pay for better water quality from that policy or willing to accept worse water quality from that policy, just as Roy was mentioning. Roy also mentioned, so let's talk about the past, what has been done. Basically, very little was done in Canada before 1985. And in 1985, there was a federal inquiry, the Pierce Federal Inquiry on Water, done for the federal government. And Andy Mueller did a report in that year. And he essentially followed the total economic value framework and estimated the value of water's contribution to the Canadian economy, so kind of adding up all of the categories that he could measure, to be between $14 and $44 billion in 2011 dollars. Unfortunately, when he was doing this work, he was hampered by a lack of data. There was just an absence of information available in the Canadian context. Many values couldn't be quantified, especially on the ecosystem value side and on the passive use value side as well. So he mostly concentrated on kind of the direct use, the extractive industries, and then on some indirect use through recreational types of values, which were available. In order to complete his study, he used a lot of US data because there's been a much more systematic approach to calculating these kinds of non-market data in the US, and used a method called benefit transfer, which is essentially what Roy was talking about in his talk, where we take values from pre-existing studies and try to transfer them to another context. I did some work with a colleague, Stephen Renzetti, 25 years later, so after the Mueller report, and we were hampered by the same problems that Andy Mueller had. We found missing data, that just not much had changed in Canada over that 25-year period. And we got essentially very similar values. And what was really missing was the ecosystem value information. Roy mentioned the Environment Canada Every database. So that began in the 1990s and was very forward-thinking on the part of Environment Canada. And essentially, when it first started, it was intended to help Canadian researchers find values that had been done in an international context. So many of the values at the beginning of Every's life were from US studies, but it was a really good way to put everything together in a kind of systematic, kind of archival library type of way. And it was a searchable database that could help researchers. In the 1990s, a handful of Canadian researchers started to do their own studies using Canadian residents, finding information for Canadian contexts. A lot of this work was along recreational types of valuation, fishing, swimming, boating, etc. There was some work done on amenity values as well. And during the 2000s, we had a few more people in Canada doing this work. It branched out to look at wetlands values, drinking water quality, irrigation types of values for agriculture, and values for industrial firms that use water in a number of different processes. Oops, sorry, I think I went back too far. Pardon me. Sorry about that. This is what happens when you're trying to get yourself all organized. But again, not many values have been done for Canada. You saw from Roy's work. In around 2010, Statistics Canada and Environment Canada worked together to have a big project to kind of consolidate and build on the knowledge that had been collected over the last number of years, and did the Measuring Ecosystem Goods and Services project, which went on for a couple of years. And that was, again, a way to try to systematize what do we know about Canada's ecosystem goods and services. Now, obviously, water is not the only thing that gives you ecosystem services. So this wasn't focused specifically on water, but it did encompass water. And in about mid-2015, I started working with Environment Canada and some biologists and other economists, and we worked to create the water quality valuation model. And Roy and Ruta are now working on extending that. But essentially the idea there was to, again, be a little more systematic in terms of looking strictly at water quality types of values, but then to link them to water quality changes so that we could see how people would express different water values according to different water quality changes, because that's essentially how we value water. We have to look at how is it being changed in order to figure out what is it people are willing to pay, either to avoid that change or to accept that change. So it's what's called a marginal willingness to pay. So let's talk a little bit about the future, and really that's where Global Water Futures comes in. What are the areas that need work and that we are trying to fill gaps with this particular project? There really has not been a systematic approach to gathering non-market values for water. Basically, there are fewer than probably 10 of us in Canada who work on this. Our work has been informed by our interests, but there hasn't been a really systematic way of thinking about, okay, here's what we need to be looking at. What's really missing is information about mining and water quality. And of course, that's very much in the news these days. What's also really missing is a lot of information about ecosystem services on a very systematic way, including flood control, services that are very important. Again, flooding has become a big issue. We usually think of Canada as having too much or having a lot of water. Sometimes having too much water is not necessarily a good thing. And finally, we also know very little about groundwater. Most of the studies that have been done so far have been focused on surface water, so rivers, lakes. Groundwater is a very important resource. Not only do we not know much about its value to people, we don't even know how much we have of groundwater. So that brings us to, again, a future. What do we need to do? We need to be investing in capacity for decision making. Why? Because we need to be making decisions about how best to manage our water going forward. And that's where this project and where Global Water Futures comes in more generally. And I just want to leave you with one last very optimistic note. StatsCan has been working on the first ever census of the environment. And one of the individuals who was involved with the MEGS project has been a real champion for this. And basically, if you think we need to know something about water quality baseline, for example, or water quantity baseline, and then look at how it might be changed as we make decisions about using land, using water. That then tells us something about how activities may change related to water, related to land, and then we can start valuing it. So we need to have that baseline information. So I'm very excited about this particular census. And even more impressive, the federal budget in 2021 has committed to funding this project over the next number of years. So we need not just a snapshot in time, but we need a commitment going forward as well to be tracking things over time, because water values will change over time. So thank you very much. That's my presentation for now. And I'm happy to take any questions, and I'll just check and see if there's anything in the chat. But I don't see anything. So I will pass it back to Roy.
Diane, I was just still in the process of answering someone's question.
Oh, of course.
No problem. So I think the next speaker is Pat.
Yeah, let me just pull up my slides here. All right, that look all right? Folks are seeing that?
Yeah.
Okay, great. This is going to be great because Diane's laid out a nice platform in Roy, so I'll be able to skip over some of it. What I thought I'd do for the next 15 minutes is just walk through 3 case studies of water valuation. And in particular, the kind of common thread amongst these sort of 3 valuation studies is all of them are centered on human behavior and understanding people's choices, and how can we use that type of information to make inference around how people are valuing different aspects of water resources. So just to jump right in, we make a lot of water choices in our life, right? On a daily basis, we're making that decision. What should we drink? Where should we get our water from? Should I have a bottled water, tap water, filtered water? Maybe on more of a weekly basis, we're thinking about where am I going to go recreate? What lake should I go visit? What river site should I go visit? Maybe I'm into fishing. Where should I go fishing? As well as sort of broader aspects, maybe more seasonal things. Should I invest in some flood protection for the upcoming flood season? Should I have some sort of averting expenditure there? As well as maybe these sort of larger life decisions just around, well, where should I live? Where should I choose to live in terms of proximity to water? As well as maybe if you're lucky enough to have a second home, where should my recreational property be, etc. The point being, from these choices, we can learn a lot about what people's preferences are for different aspects of water, as well as different value estimates. So Diane's kind of laid out the sort of toolbox of how we think about different sorts of valuation methods. Of course, just because it doesn't have a price tag doesn't mean it doesn't have value. A lot of things we value don't have price tags, and thankfully they don't have price tags. That shouldn't be an issue when it comes to our valuation aspects. Sort of have our 2 big buckets. As Diane said, we have these sort of stated preference methods that Roy was talking about, sort of people's willingness to pay, sort of asking people in structured conversations, what are the sort of trade-offs they'd be willing to make? Or we can look at the behavior. And this is sort of the area that I'm going to focus on in this presentation. What can we learn about the trade-offs that people have already made? What's sort of already embedded in their behavior? And I'm going to focus on 3 different choices in particular: recreation trips, housing decisions, and then drinking water choices. Of course, which method you should use depends on the specific context or change you're interested, available data, available resources, etc., etc. So it's not so clear that sort of one's better than the other. This is sort of the full toolbox, and we might want to use different ones in different circumstances. Just going back to Diane's sort of tree diagram, where we had sort of use values and non-use values. Of course, when we're talking about using people's behavior to infer valuation, we're really on that use value branch of the tree. So we're sort of these values that we're interested in with revealed preference methods are fall on that sort of side of the ledger. So the first one on recreation. So recreation, people spend about 2% of Canada's GDP on recreation. It's one of the most tangible ways that we interact with nature in general. And if we're interested in water, water as well. Of course, people spend a certain amount on recreation, but the benefits that we actually receive exceed that. And some recent estimates say it could be about twice as big as what people are actually spending. And that's sort of getting back to some of the concepts that Roy introduced around sort of consumer surplus and getting at the sort of values that people hold for different water resources. So this study that I'm going to chat about here, it was focusing on camping trips, so a very particular type of recreation in Alberta, so in one part of Canada, and in particular in Alberta's provincial parks. We've last couple of years, we've been working with Alberta Environment and Parks, and we have access to their camping reservation data. So I don't know if folks are into camping these days, but mostly online. You can jump online, choose your campsite, where you want to go, when you want to go, etc. So we have access to that data, and that allows us to collect a lot of information. So about 1 million different camping trips from about 70,000 people per year. And we know when they went, where they went, how many trips they took to all about 80 different campsites in the Alberta system. So we got rid of some of the campsites like horseback riding and some of the more glamping type campsites just to kind of focus on the ones You're there with a tent. So we're going to use this information and try and connect it to water quality. And I should note, this work has really been led by Nassim Amini-Karzi, who's one of the graduate students that's been working with me on this. So the big question, we had all this really cool camping data. Let's go get some water quality data. And it's challenging. There's not so like a comprehensive set of water quality data in Alberta, and as mentioned by Diane and Roy, in a lot of parts of Canada. So we also really wanted to understand the sort of temporal aspects of water quality. So water quality at these different lakes that people go for recreation, that's going to change over time. So here's a remote sensing image for Pigeon Lake, which is one of the more popular recreation destinations in Alberta, as well as one that's had a lot of blue-green algae blooms. And you can see sort of throughout the season how these sort of blooms kind of come and go. So because we know when people went, we want to include that information into our analysis. So what we ended up using here was just public health advisories. So these are sort of beach closures. So the Alberta Health Service, they'll go out and do some monitoring. If water quality exceeds a certain level, they'll post sort of a beach advisory. Don't go swimming here. Don't interact with water at that thing, at this site. And the nice thing about that is we can understand when that advisory came in and when it came off. So we have that sort of control over this sort of aspect of water quality. And so what are we going to do? We're going to take that camping data, we're going to take that advisory data, and we're going to estimate a recreation demand model. And essentially, recreation demand models, what it's trying to do, because we don't have necessarily full prices for recreation, we're going to look at the resources people give up as sort of a proxy for prices. So yeah, you have to pay for a camp fee, but you also have to drive to the campsite. That takes gas money, that takes time. And so we're going to use that information to understand the trade-offs that people are making when it comes to different water quality choices. Now, of course, this is challenging because when it comes to hot days, people like them, and blue-green algae like hot days. So if we just kind of ran a naive analysis, we could find that people like blue-green algae. But it's really because we have this sort of temperature mediating this effect. So we got to be really careful when it comes to their estimation of these water quality effects. Skip over all the gory details. Just what do we find here? We find people less likely to go to these parks that are under an advisory. In a way, that's sort of a good thing, you know, from a public health perspective. But that also means it's having a negative impact on people's well-being because it reduces the set of campsites that they're considering when they're going camping. And if we do our sort of estimation and valuation method applied here, it's about $15 per camping trip. So if there was an advisory at a certain park, that's going to reduce the value people are getting from trips by about $15. We can use that number, and currently we're working with Alberta Environment and Parks to kind of build out, well, what is the total sort of benefits that Albertans would receive from reducing all blue-green algae warnings in the province. So we can use that sort of information to get at that. So that's the sort of case study one. How can we can use sort of recreation demand models as our first approach. The second one is looking at housing decisions, and specifically, is local water quality affecting people's decisions of where am I going to buy a house, or even how much am I going to pay for different houses. And here we're going to jump across the country to cottage country in Ontario. So this is just sort of north of Ontario, or north of Toronto, and a lot of lakes in this area. This is sort of like the Muskokas, if you're familiar with that. A lot of properties, a lot of private properties, a lot of lakes with differing water quality. And so for this approach, we're going to estimate a hedonic price model. And the idea behind this is we're going to try and explain house prices looking at variation in a whole bunch of characteristics: how many bedrooms, what's the square footage, does it have a garage, all the sort of traditional things that we would think would impact house prices. But then also ask that question, well, what about the local water quality? Is that going to be impacting the house price? And how can we use that information to understand sort of what people are willing to pay to live in homes, or a lot of these are recreational properties that have better water quality. So we're going to collect a whole bunch of data on residential house sales, about 10 years of data. And that also had information on different structural characteristics of the home, how big is it, how many bedrooms, etc. And we're going to try and pair that to some water quality data. Of course, what water quality do people care about when they're buying a home? Not too many people are going out when they're buying a home and sort of measuring the water quality at the local lake. So that's sort of an open question in this literature. What's actually driving these decisions? And of course, we can think about sort of what's our ideal data set, what do people actually care about, as well as just sort of seeing what's available. What water quality do we have at these different lakes? And we sort of focus on two different ones here. One that sort of maybe captures sort of clarity. And this is sort of something that gets used a lot because people can kind of assess water quality through sort of how clear it is. That might be one way. So we're going to use Secchi depth there, as well as sort of maybe some proxy of quality, sort of this total phosphorus. And again, this isn't people going out and measuring the total phosphorus at the lake, but maybe they're understanding sort of some of the broader ecosystem health that's associated with the lake. So we're going to be looking at this sort of total phosphorus measure. And this is work with Rashadur, who's a graduate student at University of Saskatchewan, and Richard Vine from Guelph University, or University of Guelph. So we're going to try and look at these different water quality measures to see, do they impact house prices, as well as, well, how far away does the water quality, how far does water quality impact houses? So houses that are right by the lake, what about 500 meters away? What about a kilometer away? Can we tease out different sort of impacts of water quality on housing prices through these different distances? And so that's how I'll just sort of present these results here. And the headline result is we do find a positive association between sort of improved water quality, sort of greater Secchi depth, and then I'll talk about total phosphorus in a second, and house prices, but only for houses that are close to the lake. And as you can see on the x-axis there, it's a little small, but it looks like around within a kilometer of the lake, houses sort of have this sort of positive association between water quality and house prices, but then after that, it sort of dies out. That's for Secchi depth. Sort of something similar is going on with total phosphorus, but it's not such a clear linear relationship for total phosphorus. So total phosphorus at really low levels is sort of bad for the environment. Really high levels is bad for the environment. There's sort of a sweet spot in the middle. And actually we find that in the data, that houses that are near lakes that have total phosphorus sort of in the 10 to 30 milligrams range, sort of this like threshold range, have a higher house price relative to houses that are near lakes that are further, or in total phosphorus that is very low or very high. So this is another way that we can try and understand people's decision of house purchases to back out information that's implied around sort of water quality improvements. So that was number 2. And then number 3 is about drinking water choices. So there you are, you're going to grab a glass of water, you're taking it from the tap, maybe some filtered water, maybe some bottled water. And we can think about all the different factors that would influence people's choice of one or the other, the convenience, the taste, maybe the appearance, as well as what it costs. Those are all sort of common factors. Well, what about health risks associated with these different drinking water sources? And this is some work that Diane and Vic, who are also part of this project, and Craig Schramm did a few years ago, trying to understand people's sort of perceived health risks associated with these different drinking water sources, and how can we use that information to back out values that people are placing on trade-offs between reducing health risks associated with drinking water sources. So in Canada, sort of the objective mortality risks are relatively low. I mean, with the caveat, they're relatively unknown. So there's not great data on sort of the mortality health risks that people get from drinking water in Canada. Estimated about 90 deaths per year in Canada from this. Of course, this is just extrapolated from the US using the good old divide by 10 rule. So that's sort of the best estimates we have in the country. Just take the US number, divide by 10. So that's sort of objectively perhaps quite low, but the perceptions around health risks might be quite different from that. And there's been a lot of high profile drinking water incidents. Walkerton about 20 years ago, where we had 7 people die. We've had some big sort of different E. coli outbreaks in different drinking water systems across the country. And so people might perceive these health risks quite differently. We've also had sort of our national shame with the long-term drinking water advisories on First Nation reserves and in Indigenous communities. So people's perceptions around drinking water might be quite different from these sort of objective mortality risks. So in this study, we wanted to collect information on what people are consuming in terms of tap, filtered, or bottled water, how much money they're spending on these different sources, as well as ask them different perceptions around what they think in terms of mortality risks associated with these different drinking sources. We're going to use that information and estimate an averting behavior model. And so that's sort of the third method that economists use under this big sort of revealed preference method bucket that sort of understands, in this case, it's sort of a negative thing associated with water quality or health risks. So what are people doing to avoid or avert those sort of health risks? When it comes to mortality health risks associated with drinking water, these are sort of micro risks, right? I mean, these are not that large in most situations. So eliciting these types of risks from people is challenging. So a lot of work went into designing how can we actually elicit people's risk perceptions. There's a sort of excerpt from the risk ladder that was used that helped people put the drinking water health risks alongside other types of health risks that they might face in their life. So we take this information on the perceived health risks, and we're interested in a couple of questions. One is just what are people's mortality risk perceptions across these different sources, and what we find is tap water is associated with the highest health risks, then filtered, then bottled. So that sort of maybe makes sense with what we were thinking ahead of time. We also find that these perceived mortality risks are a significant predictor of what people are choosing, as well as how much money they're spending on these different types of water sources. So there, people seem to be making that trade-off between spending money or choosing these alternative sources and these sort of risk reductions. And we can use that information to understand the economic value that people are placing on these, again, really sort of small 1 in a million, 10 in a million risks of death. Getting a little morbid here on a beautiful sunny day here in Saskatoon. But, you know, and we find out it's about $3 to $5 per year to reduce your chance of death by 1 in a million. So we can use this sort of information to help understand sort of some of the health risks and the value of health risk reductions with these different water sources. Okay, so those are sort of three of the main approaches that we use as economists to help understand the economic value associated with different water resources, all in the revealed preference sort of bucket of methods. But when we actually look at the literature, we've seen there's actually been quite a decline in the use of revealed preference methods in Canada. Now, this is across all different types of non-market valuations or ecosystem services. So not just water, but it extends to water as well. So we've really seen this increasing trend towards stated preference, sort of survey-based methods, and a real drop-off in revealed preference methods, which is interesting, and I'd be interested in people's thoughts of exactly why. I have a few ideas, but I'd be interested in folks' ideas of why that might be the case. But I think that we're really missing out on some of the utility of these revealed preference methods because they're sort of grounded in actual behavior that people are making. So there's my sort of plea to maybe do a little bit more of this type of research in Canada. So what am I talking about? Just to wrap up here, what's the main points? I think there's a lot we can learn about from people's behavior and choices on how Canadians value water. We talked about quality, clarity, health risks, maybe even access. But what else? What else could we use these methods for in the Canadian context? We sort of have the tools, we have the methods, but we don't have that many empirical applications as we saw on that previous slide. And they're actually declining over time as a proportion of non-market valuation work in general. And of course, I'll do the classic lament for better data. You know, one of the main challenges is we need an understanding of the objective and perceived measures of water quality. And often we don't have that in Canada, and it's hard to use these methods when we don't have a good understanding of what people are responding to in these different contexts. But even larger than that, just from a scientific sort of data gathering standpoint, we really don't have that much information on just how people are interacting with water in general. especially when it comes to things like recreation. We don't have a lot of these sort of large scale data collecting initiatives that they do have, as Diane said, south of the border. We have to look down there. And so that also limits our ability to use these types of models. So I think better data on the actual sort of behavior, as well as those scientific measures of water quality. Additional work that can be done of how can we aggregate these different aspects of water quality. It's going to be very different whether we're talking about recreation or health risks or other sort of ecosystem services or some of the non-use values that Diane was mentioning. So how can we aggregate these water quality benefits from all these different methods and applications across space and across time? And I think there's a real use and potential for sort of combining revealed and stated preference studies. And that's one way that we can kind of leverage the strengths of both, because they both have strengths, they both have weaknesses. So how can we kind of use both of those in tandem to address that? And I'll leave it there in due to time. But thanks for your attention. All right. So I have a couple of questions here. I am cognizant of the time because I know we have 18 minutes and I want to give Reuter time. I'm just going to answer quickly here on Paul. All right, Paul, I'll answer you in the chat. We can just follow that up there, and then that'll give Ruth sort of a time to do her presentation. So I'll hand it back to you, Roy.
Thanks, Pat. So we've got the last presentation of today by Ruth Pinto from University of Waterloo. Can you share your screen?
Yes. Okay.
Pat, maybe you need to take it off or not? Oh, yeah.
Can you see my screen now?
Yeah.
Okay.
Just run it in the perfect.
Okay. So good afternoon. My presentation today is going to talk more on some of the challenges that we face when we try to link water quality changes to recreational users' responses to those changes. And so it will focus more on the biophysical aspect of modeling recreational demand. And as a next step, we then aim to link to the economic value of those water uses. A key issue, as Pat mentioned in his presentation, when we deal with cultural ecosystem services, and more specifically with recreation services, is try to understand the importance of explanatory factors or the underlying factors that determine recreation visits, and so influence people's decision on where to go and what to do. And there are several enable factors that contribute to and that influence this decision, like, for example, having access to a recreational site through roads or having good infrastructure like trails in a park. But besides these enabling factors, there are also a number of environmental factors that affect and influence people's decision. And this can include, for example, the presence of certain fish species for sport fishing or a good water quality for swimming, for example. And so to establish these cause and effect relations between water quality conditions and the recreational demand, it's not always easy. And usually it's done through conducting surveys, which can be costly and time demanding. And so a new approach that has been suggested is to use the geotag data that is uploaded in social media websites such as Flickr or Twitter, and to use that data to determine where people are going, what they are doing, and what they value. And one of the questions that has been suggested that this approach can help to answer is how water quality affects tourism and recreation. And this leads us to the main objective of this work, where we try to investigate the usefulness of geotag data to quantify water-related recreation activities using the Grand River watershed as a case study. And more specifically, we were interested in understanding where are the water-based recreational hotspots located, which watershed characteristics help to explain those recreational visits, and how the water quality changes might influence water-based recreation patterns in the future. And so, as mentioned, we used the Grand River watershed as a case study, and this is the largest Canadian watershed draining into Lake Erie. And the water quality in the watershed is mainly influenced by both non-point sources like wastewater treatment plants, but also by runoff from urban and agriculture areas. And these are actually the two main pressures affecting water quality in the watershed, with almost 1 million residents living inside the watershed area, and with almost 70% of the total area dedicated to agriculture. And so, to try to mitigate the impact of these pressures, several measures have been implemented, such as best management practices, but also nature-based solutions, such as wetlands restoration, that aim to improve the water quality along the watershed. And the watershed also provides several cultural ecosystem services. It has 12 conservation areas, and some of the recreational activities are fishing, swimming, or boating in the river and lakes inside the watershed. And here in this diagram, I just wanted to show that some of the most popular recreational outdoor activities along the watershed are water-related activities that are highlighted here in the red bars. And so, to try to assess and quantify how water quality changes impact recreational demand, we use the Invest recreational model that help us to predict recreational special spread of persons day, given a set of variables that is going to tell us what influence people to go and to do what. And so this model basically allows us to map the current patterns of recreational use and gives us the option to estimate future patterns of use under changing conditions. And it relies on geotag photos that are uploaded in Flickr website that are used as a proxy for visitation. And the model estimates a photo user day that is the unique combination of user and recreational site. And this approach has been used in several case studies worldwide, and it has proven to be a reliable indicator for visitation rates. So we started by implementing this model in the Grand River watershed, and we considered the time period between 2005 and 2017. And the model basically relies on a linear regression that allows us to regress the photo user's day against a set of variables. And in our study, we considered variables such as the presence of water bodies, either river, lakes, or wetlands. We also considered indicators for water-related recreation, such as fishing or canoeing. We also considered non-water related indicators, such as bird watching hotspots, for example. And we considered several landscape characteristics, such as distance from urban areas. And here we were especially interested in understanding how water quality would influence recreation visits. And for this, we included metrics such as total phosphorus and sediments in the water bodies. And we applied this model to two different spatial scenarios. We considered the conservation areas across the watershed, and this corresponds to just over 1% of the total watershed area. And we tested the visitation rates across the entire watershed. And because we were interested in estimating the impacts that improving water quality would have on the recreation visits, we estimated how restoring 2% of wetlands in farmland area would impact the water quality, and how this water quality improvement would then impact recreational demand. And here we used to calculate this water quality improvement, we used the SWOT model for the entire watershed. And so we started by analyzing the visitation rates across the watershed, and we can see that there was a peak in visitations between 2008 and 2012. And almost 50,000 photos have been uploaded inside the watershed. Of those photos, just over 2% were inside the conservation areas. But when we divide those photos by the total area, we can see that this picture changes, and inside the conservation areas, there's a much higher intensity of photo users than when considering the entire watershed. So we looked at the first research question that we were analyzing, and we tried to understand where are the recreation hotspots located across the Grand River watershed. And we can see that there's a wide spread of visitations across the watershed, and the darker the color, the more photo users there are. And what we can see is that the darker colors are located also around urban areas. So we try to understand what was the overlap between these darker colors and the more photo users there and the urban areas. And if we consider the photo users there with less than 1, there's only an overlap of less than 30%. However, as we increase the number of photo users there, this overlap increases from 79 to 100%, which suggests that the recreation hotspots in the Grand River watershed are in and around the urban areas. So once we knew where people were going, we tried to understand which watershed characteristics would help us to explain those recreational visits. And here in this table, in green, are the variables that are statistically significant and positive, and in red, the variables that are statistically significant but negative. And what we can see is that the presence of water bodies, either wetlands or lakes, have a positive effect on visitation rates, meaning that the presence of these water bodies tend to attract more recreational users. We also tested the water-related indicator proxies, and we can see that the presence of beaches, for example, is also positive, meaning that it also tends to attract more visits, and river stretches used for fishing also seem to have the same effect. We also tested the impact that non-water related indicators might have. And here, for example, we can see that the presence of trails tend to attract more visits, or for example, bird watching hotspots tend to attract more people inside the conservation areas. Having good access to these recreational sites also is positive when we consider the watershed as a whole, here given by the proxy of roads. We also could see a very clear distance decay from urban areas, especially for the conservation areas. And we can see that areas that have higher loads of phosphorus and sediments have less visits than areas with better water quality. So once we knew which variables were affecting the visitation rates, we tried to understand how improving water quality could influence future recreation patterns. And we did this for the conservation areas and for the watershed as a whole. And for the conservation areas, we can see that it seems that most the conservation areas located in the central and southern part of the watershed seem to have a higher number of photo users there if the water quality changes. And a similar pattern is also observed when we consider the watershed as a whole, where higher photo users days are expected in the central and southern part of the watershed. So in conclusion, we aim to demonstrate the usefulness of geotech data to map recreation visit patterns by showing visitor spatial preference. And we saw that the presence of waterfront areas, either lakes or wetlands, proved to have a significant impact on recreation. And water-based recreational activities, such as the presence of beach or fishing, showed a significant and positive relation with photo users day. Having access to and having good infrastructure for recreation also showed to play a significant role on the number of photo users there. We also saw that water quality showed a significant relation with the number of photo users there, but it has a relative small contribution when compared with the other covariable groups. So the next steps would be to analyze the water-based geotech data patterns and to assess the economic value of water-related recreational activities based on willingness to pay values for these different activities. Thank you. If there is any question.
I don't see any in the Q&A. this was another example of actual behavior of people visiting specific sites, making pictures, and making those pictures available on social media and using social media to infer recreational demand. So it's a different way compared to what Pat was talking about, but in a sense very similar again as well, because it's based on actual behavior, and the presentation that I gave was mainly based on studies where people were asked for their hypothetical willingness to pay for improvements in water quality. I see one encouraging comment from Maren in the Q&A. So we're 4 minutes to the hour, unless there are still some other questions. I propose we draw to a close, and we thank everyone for participating in the session. So on behalf of myself, Pat, Diane, and Ruth, who organized this session, thank you all very much for participating. Pat, Diane, Ruth, anything else you want to share with the participants?
Oh, thanks for coming, everyone. If you do have any questions on where we're going with our research or anything on our presentations, just feel free to reach out. Yeah, or stick around. We can chat right now.
Perfect. Thank you all, and enjoy the rest of your day. So I propose we then close the session. Thank you all.